This question is about the intensity of the wave and its variation with respect to distance. So we are supposing that this is the source, and it's not mentioned it is the source of which kind of wave, but you can consider it either the source of a sound or the light, because in both cases intensity varies as inversely proportional to the square of distance. So I is inversely proportional to the distance of square, which is also called inverse square law. But in our new IB syllabus, it is clearly mentioned that this intensity, you can take this as a apparent brightness is equals to luminosity, which is equivalent to the power in the previous IB syllabus divided by 4 pi d square, whereas the d is equivalent to the distance r. So if I write the same inverse square law, so I can write the apparent brightness, means in other words the intensity is inversely proportional to the distance square. So we are assuming that this is the source of the wave and this is the observer where we are measuring the intensity. So this is the distance d, whereas the power of this source, in other words the amount of energy that this source is producing in every second or per unit time, is b, which is equivalent to the L luminosity in our new IB syllabus. So if we measure the intensity I, let's say if we have measured I, so we can write this I is equals to power p divided by 4 pi d square. So this is the amount of intensity that was measured at the distance d. Now in this question it is said that if we make the power of the source half, means that now it is producing a half amount of energy in every second, then where we should place this point or this observer so that it will receive the same intensity of the wave. So obviously if the power is half now, it means that we must take that point closer to the source. So this is a new distance t prime. So have to intensity same amount of intensity. So let's write the value p by 2 divided by 4 pi d prime square. Now we can equate these two equations because intensity is same. So this power and this is cancelled out, 4 pi and 4 pi is cancelled out, and we get 1 over 2d prime square is equals to 1 over d square, and d prime square, that is the new distance square divided is equals to the d square over 2, and from here we can easily get the distance at which the intensity would be same, that is taking the square root on both sides. So you will get this answer. So the right answer is option A.